Okay, in this video I want to give a short introduction on what they call complex numbers, and specifically imaginary numbers. I think people have a little bit of difficulty understanding what an imaginary number is. They think it's something that doesn't exist, but actually they do exist pretty well. And so I would like to talk a little bit about why imaginary numbers or complex numbers even came into being. Okay, you can ignore this a plus or minus bi for just a second, and let me talk a little bit about the why of complex numbers. So I want to lay the foundation here just a little bit and talk about real numbers. Now, what are real numbers? And I just tell my students that real numbers are just numbers that exist on a number line. Okay? And if you have just a regular number line, we've used this for ever since our first grade, even before first grade. And you've got positive numbers at one end, right? So 1, 2, 3, 4, 5. And then you have 0 in the middle. And at the opposite end, you've got negative numbers. And when you think about all the numbers that we've used really ever since we learned to count, they're all real numbers, aren't they? So all our problems, all our algebra problems, for example, are created with real numbers. All of our solutions are real numbers. And we did many things to those. We added, subtracted, multiplied, divided them. Then we started using exponents, for example, and then we started taking roots or square roots of them, and that's actually where the problem came in. And all those rules were very consistent with one another until we got to something that looked like this, and that's using a radical. And I'll just put a number under here that's, for example, something like -4. And it could be any really negative number. Well, we had a problem here. You can't take the square root of a negative number, because remember what square roots mean. Square roots mean that, something times itself will give you the number. But we know that if we took 2 times 2, for example, a real number, 2 times 2, you would get +4, so that's not the square root. What if we took the -2 times -2? Well, that's going to become a +4 again, and again we don't get the square root of a -4. So how do we deal with this? They basically had to come up with a whole new number system in order to take care of this, and the number system that they came up with is the opposite of real numbers, and that's what we call imaginary. Now again, it doesn't mean that they don't exist, it just means that they're the opposite of real numbers. And specifically they deal with square roots of negative numbers. Now in order to do this, let me just say one last thing. They call both of these together, imaginary numbers and real numbers, they call both of these together complex numbers. Okay, so think of the top of the heap used to be real numbers, now the top of the heap is complex numbers, and it includes both imaginary and real numbers. So let's talk a little bit about imaginary numbers. There's 2 identities that you need to know. Think of them as the bridge between real numbers and imaginary numbers. And the 2 identities that I want you to memorize are this. That if you take the square root of a -1, we're going to call that I, because there's no real number that exists for that. So we're going to call that I. Okay, so that's your first identity. Now your second identity is this. If you square I, you're going to get -1. Okay? So using those 2 identities, let's see what a problem would look like. Let's simplify something like the square root of -4. So this will be our first example. So what is the square root of -4? The way you simplify that, these are my Roman numerals, this means steps, that doesn't mean imaginary number, okay? The way you simplify that is to do this. You break this up into the square root of 4 times the square root of negative 1. Then you go ahead and take we'll call this step 3, you take the square root of 4, which is plus or minus 2, and then you transform the identity of the square root of negative 1 into I. Step 4, so the square root of a negative 4 is plus or minus 2I. And if you want to write this in complex number form, you'd put a 0 in this spot, which is the A, in our A plus or minus BI. Now, let me give another example. Let's say I want to add, and call this example 2. 1 plus the square root, no, sorry about that. Let's say I want to add 1 plus 2I plus 2 minus 3I. So those are just two imaginary numbers, right? How would you add them? Well, you would add the A's, and you would come up with 3, and then you would add the B's. In this case, it would be 2I minus 3I, and you would just get minus 1I. And there is your answer on that one. So what does that tell you? Essentially a couple things. Imaginary numbers or complex numbers are pretty much binomials. So complex numbers are binomials. And you should treat them as binomials when you're adding and subtracting. You're going to add and subtract the like terms. So the A parts, you're going to add the A parts and subtract the A parts, or you're going to add the B parts and subtract the B parts. I like to think of this part of the complex number as the real numbered part, and this part as the imaginary numbered part. And complex numbers are made up of real parts and imaginary parts. I hope that was helpful. I'm going to do some more examples in upcoming videos.